On the 7th day of December, 1941, just off the coast of Oahu, in the territory of Hawaii, approximately 10 miles out to sea, Lieutenant Commander Mochitsura Hashimoto stood as the torpedo officer aboard the Imperial Japanese Navy submarine I-24. Through the dim pre-dawn light, he observed as the submarine's smaller vessel detached, embarking on its assault toward Pearl Harbor. Hours later, with flames erupting from Battleship Row and smoke obscuring the Hawaiian sky, Japanese officers throughout the Pacific rejoiced at what appeared to be an improbable triumph against a colossal industrial power, one they had been cautioned could never be overcome. Around Hashimoto, his fellow officers voiced their conviction that American naval might have been irrevocably crippled. They believed the technological superiority of Japanese weaponry would guarantee their continued dominance. What eluded them entirely was the understanding that within those burning harbors lay the very seeds of Japan's eventual ruin, and that the instrument of their empire's downfall was already being readied for deployment aboard American submarines, afflicted by profound flaws and dismissed by Japanese intelligence as evidence of American technical inadequacy. The calculations leading to Japan's naval defeat were not being etched in the dramatic carrier engagements that would capture public attention, but rather in the persistent mechanical failures of American torpedoes, which paradoxically would pave the way for the most devastating submarine offensive in naval history. This cycle of mutual misapprehension and technological disdain had commenced long before the initial bombs descended upon Pearl Harbor. The hubris began on the 13th day of May, 1940, when an anonymous informant, whose identity remains classified to this day, furnished the United States Naval Attaché in Tokyo with detailed intelligence regarding the Type 93 oxygen-fueled torpedo. This weapon, which Allied forces would later dub the Long Lance, represented the zenith of Japanese naval engineering and a technological marvel that should have instilled dread in American naval planners. Its specifications were extraordinary, and to Western observers, almost inconceivable. With a remarkable range extending beyond 22,000 yards at a speed of 48 knots and 33,000 yards at slower velocities, it carried a warhead packed with 1,080 pounds of high explosive. By any measure, it was the world's most advanced torpedo. The informant provided technical schematics, performance metrics, and operational directives that outlined precisely how Japanese destroyers and cruisers would deploy this weapon in nighttime surface engagements. The Office of Naval Intelligence meticulously reviewed the report, forwarding it to the Bureau of Ordnance for a technical assessment. The resulting conclusion proved to be catastrophically incorrect. The Bureau entirely disregarded the intelligence. The rationale was straightforward, reflecting the prevailing biases within Western military thinking concerning Asian capabilities. Japanese engineers, the Bureau concluded, could not possibly have devised a torpedo superior to existing American designs. The use of pure oxygen as an oxidizer, while theoretically feasible, was deemed excessively perilous and too sophisticated for an Asian naval power to master safely. Consequently, the report was filed away and largely forgotten. Over the ensuing months, as tensions with Japan intensified, this intelligence lapse would cost thousands of Allied lives and numerous warships. This dismissal was indicative of a broader disdain that permeated Western military perceptions of Japanese capabilities in the years leading up to the conflict. Admiral Richmond Kelly Turner, who would later command amphibious forces in the Pacific and earn 4 Navy Crosses for his service, had testified before Congress in 1940, asserting the inferiority of Japanese pilots due to supposed racial characteristics that impaired their vision and spatial awareness. These prejudiced assumptions, presented as scientific truths, posited that Japanese aviators lacked the requisite night vision for effective combat, that their technical training fell short of Western standards, and that their aircraft were merely imitations of Western designs constructed with inferior metallurgy. Army Air Force's intelligence assessments from 1941 confidently declared the Zero fighter to be a derivative of obsolete American designs, destined to be no match for American aircraft in combat. These presumptions would exact a heavy toll in American lives during the initial months of the war, as Japanese pilots flying technically superior aircraft and employing sophisticated tactical doctrines dominated the skies over the Philippines, Wake Island, and the Dutch East Indies. The repercussions of this intelligence failure became evident almost immediately following the attack on Pearl Harbor. 7 American cruisers would fall victim to Type 93 torpedoes during the Pacific War. The heavy cruisers Quincy, Vincennes, Astoria, Chicago, and Northampton were sunk by long lances fired from ranges the Allies deemed impossible. 9 destroyers were also lost to these weapons. The fleet aircraft carrier Hornet, already damaged in the Battle of Santa Cruz, sustained the final blow from Type 93 torpedoes launched by destroyers. Over 3,100 American sailors perished directly from long lance hits. In most instances, the ships believed themselves to be safely beyond torpedo range when these weapons struck. Lookouts scanning the horizon perceived no enemy vessels close enough to pose a threat. Captains maneuvering their vessels felt they were operating outside the danger zone, based on intelligence estimates of Japanese torpedo capabilities. Then, long lances launched from cruisers and destroyers at distances of 15 or even 20 miles would impact their hulls, detonating with devastating force. The initial engagement occurred during the Battle of the Java Sea on the 27th of February, 1942. Dutch Rear Admiral Karel Doorman, commanding a hastily assembled contingent of American, British, Dutch, and Australian cruisers and destroyers, led his ships out of Surabaya to interdict a Japanese invasion convoy approaching Java. The Allied force comprised the heavy cruisers Exeter and Houston, the light cruisers De Ruyter, Java, and Perth, and 9 destroyers, representing 4 distinct navies with differing tactical doctrines and significant language barriers hindering communication. Doorman was a capable officer thrust into an untenable situation, commanding vessels that had never operated in concert, with crews exhausted from months of continuous retreat, facing a Japanese force that had trained together for years and operated under unified command and doctrine. The battle commenced at 1600 hours when Japanese and Allied forces made visual contact from distances beyond the effective range of most Allied vessels. The Japanese heavy cruisers Haguro and Nachi, along with the light cruiser Naka, supported by destroyers, maneuvered to bring their torpedo batteries to bear. At 16:33 hours, the light cruiser Naka launched 4 Type 93 torpedoes from a range of 15,000 yards. Her escorting destroyers followed, deploying 27 more torpedoes between 1640 and 1645 hours from ranges between 13,000 and 15,000 yards. At 1652 hours, the heavy cruiser Haguro added 8 more torpedoes from the almost unbelievable distance of 22,000 yards, over 11 nautical miles. The sea between the Japanese and Allied formations became a maelstrom of nearly 40 long lances, running at depths of 12 feet, leaving no wakes, their oxygen propulsion systems emitting no telltale bubbles. Allied lookouts and sonar operators, trained to detect torpedoes at much shorter ranges based on American and British torpedo capabilities, saw nothing until it was too late. At 17:13 hours, a single Type 93 struck the Dutch destroyer Kortenaar amidships. The half-ton warhead detonated against the destroyer's thin hull plating, the explosion breaking her back. The Kortenaar jackknifed and sank in less than 2 minutes, taking most of her crew of 150 with her. Allied commanders, unable to fathom torpedo attacks from such extreme distances, concluded that submarines must be responsible. Throughout the remainder of the battle, Allied vessels maneuvered frantically to evade what they believed to be submarine-launched torpedoes, disrupting their formations and preventing coordinated assaults on the Japanese surface fleet. The battle raged for 7 hours as Doorman repeatedly attempted to reach the invasion transports, while Japanese surface forces maneuvered to impede him. The heavy cruiser Exeter sustained a hit from an 8-inch shell that penetrated her boiler room, reducing her speed and forcing her out of formation. The British destroyer Electra was sunk by gunfire after launching a gallant but futile torpedo attack. Dorman's force, reduced to 4 cruisers after the American destroyers withdrew due to fuel and ammunition shortages, continued searching for the invasion convoy through the night. At 23:25 hours, Japanese cruisers Haguro and Nachi, tracking the Allied force by radar, launched another salvo of torpedoes from long range. At 23:32 hours, one Type 93 struck the light cruiser Java. The explosion ignited her magazines. The Java blew apart and sank almost instantly, taking 512 of her crew of 600 with her. Minutes later, at 23:38 hours, another long lance struck Dorman's flagship, the De Ruyter. The torpedo detonated against the cruiser's ammunition magazines, triggering a catastrophic secondary explosion. The De Ruyter broke in half and sank within minutes, killing Rear Admiral Dorman and 345 of his crew. The Battle of the Java Sea cost the Allies 2 light cruisers, 3 destroyers, and approximately 2,300 sailors killed. Japanese losses consisted of 4 transports struck by errant torpedoes from their own cruiser, the Mogami, and minor damage to 1 destroyer. The invasion of Java proceeded without further impediment. More significantly, the battle underscored the lethality of the Type 93 torpedo and the Allied inability to counter it. Yet, American intelligence, analyzing battle reports and interrogating survivors, refused to accept that surface ships had launched torpedoes from the reported distances. The prevailing assessment remained that submarines were the culprits, that Japanese surface torpedo capabilities were comparable to Allied weapons, and that reports of extreme-range torpedo attacks were exaggerations by exhausted crews under immense stress. This pattern persisted at the Battle of Savo Island on the 9th of August, 1942, one of the most calamitous defeats in United States Navy history. At 1:43 hours, Japanese float planes dropped parachute flares over the Allied cruiser force protecting the Guadalcanal landings, silhouetting the American and Australian ships against the night sky. Within minutes, Vice Admiral Gunichi Mikawa's formation of 5 heavy cruisers, 2 light cruisers, and 1 destroyer had closed to torpedo range. The engagement lasted 32 minutes. When it concluded, the Australian heavy cruiser Canberra was sinking, having sustained 2 Type 93 torpedo hits and 24 8-inch shell hits. The American heavy cruisers, Quincy, Vincennes, and Astoria, were all ablaze and would sink before dawn. The heavy cruiser Chicago limped away with her bow blown off by a torpedo impact. Over 1,000 Allied sailors perished that night, trapped below decks as their ships burned and sank, or killed instantly by torpedo detonations that tore their vessels apart. American survivors reported torpedoes originating from impossible ranges and directions, weapons that left no visible wakes, and detonations from angles suggesting Japanese torpedoes could alter course and maneuver after launch. Intelligence officers dismissed these accounts as combat confusion, the natural inclination of survivors to exaggerate threats and rationalize defeat. The assessment remained that Japanese torpedoes were roughly equivalent to American weapons, perhaps marginally superior in certain aspects, but not dramatically so. This willful ignorance of evidence would persist until 1943, when the examination of intact Type 93 torpedoes recovered from sunken Japanese destroyers finally confirmed the accuracy of pre-war intelligence. By then, thousands of Allied sailors had been lost, and dozens of ships had been sunk by a weapon that American intelligence insisted could not exist. This deliberate disregard for Japanese technological prowess mirrored Japanese attitudes toward American weaponry, creating a symmetrical intelligence failure that would have vastly different repercussions for the 2 powers. As American submarines commenced their war patrols in December 1941, Japanese naval intelligence officers compiled reports on early American torpedo attacks with barely concealed satisfaction and growing confidence that the submarine threat was manageable. The reports chronicled successive spectacular failures, malfunctions so consistent they suggested fundamental flaws in American torpedo design and American submariner training. On the 14th of December, 1941, a mere 7 days after the assault on Pearl Harbor, the submarine Seawolf, commanded by Lieutenant Commander Frederick Warder, encountered a Japanese freighter anchored off the southern coast of Mindanao in the Philippines. Ward maneuvered his vessel into a perfect attack position at a range of 3,000 yards, targeting a stationary and unescorted vessel. He launched 8 Mark 14 torpedoes, the standard armament of the American submarine force, each costing over $10,000 and representing months of production effort. 7 torpedoes missed entirely, passing beneath the target or veering off course. The 8th struck the freighter squarely amidships. The Seawolf's crew heard the dull clang of metal against metal through the submarine's hull. No explosion followed. The torpedo, its warhead packed with 643 pounds of Torpex explosive, had directly impacted the target and failed to detonate. The freighter, its crew alerted to the submarine's presence, got underway and escaped, while the Seawolf dove to evade a depth-charge attack that never materialized, as the Japanese vessel was not equipped with anti-submarine weaponry. On the 24th of December, 1941, Christmas Eve, the submarine Sargo, commanded by Commander Earl R. Jacobs, encountered 4 Japanese cargo ships off the coast of Indochina, proceeding in a loose convoy without escort. Jacobs maneuvered his vessel into textbook attack positions, firing 3 torpedoes at each of 4 targets, a total of 12 torpedoes from ranges between 1,000 and 2,000 yards. The conditions were ideal: calm seas, excellent visibility, and the targets maintaining steady courses and speeds. Every single torpedo either missed entirely or malfunctioned. Not one detonated. Through his periscope, Jacobs observed torpedo after torpedo pass beneath targets, strike and fail to explode, or detonate prematurely without causing damage. He launched his final attack, the last 4 torpedoes in his forward tubes, at a large cargo ship that had stopped and was lowering boats to investigate the situation. All 4 torpedoes ran beneath the stationary target. The Sargo returned to Manila Bay on the 30th of December. Her crew demoralized, having expended all 24 torpedoes aboard without sinking a single vessel. Commander Jacobs submitted a scathing after-action report, stating unequivocally that his torpedoes were running far deeper than their set depths, passing harmlessly beneath targets. The Bureau of Ordnance in Washington, responsible for torpedo development and production, dismissed his complaints with barely concealed disdain. The problem, Bureau officers insisted, lay with submarine commanders who failed to grasp proper torpedo maintenance, with crews not adhering to pre-launch procedures, and with captains unable to execute proper attack approaches. The Bureau's stance was that the Mark 14 torpedo was the most sophisticated, most thoroughly tested weapon in the American arsenal, and any failures were attributable to operator error, not design flaws. This position would be obstinately maintained for nearly 2 years, during which American submarines launched thousands of defective torpedoes, and Japanese merchant ships sailed safely to port with American torpedoes lodged unexploded in their hulls. Japanese intelligence officers, monitoring American submarine radio transmissions, decrypting American operational messages through partial breaks in American codes, and interrogating crews from sunken submarines, compiled detailed reports on American torpedo failures. These reports reached Imperial Naval General Headquarters in Tokyo by early 1942 and were analyzed by intelligence staff officers who drew precisely the wrong conclusions. American torpedoes, they reported, were primitive weapons plagued by fundamental design flaws. American submariners were poorly trained and lacked the aggressive spirit essential for effective combat operations. The vaunted American industrial capacity was producing inoperable weapons, ships inferior to Japanese vessels, and equipment that faltered under combat conditions. This assessment, based on accurate observations of American failures, but fundamentally flawed in its interpretation of their meaning, would prove to be one of the most catastrophic intelligence judgments in modern warfare. Throughout 1942, the pattern repeated itself with numbing regularity across the Pacific. American submarines stalked targets, maneuvered into attack positions, launched torpedoes that should have guaranteed kills, and achieved nothing. The statistics told the story. In 1942, American submarines in the Pacific fired 1,442 torpedoes at Japanese targets. They claim to have sunk 211 ships, totaling nearly 1.3 million tons. Post-war analysis of Japanese records, conducted by the Joint Army-Navy Assessment Committee, revealed the actual figures to be 109 ships totaling 41,871 tons, barely 3% of the claimed tonnage. Submarine commanders filed report after furious report, detailing torpedoes that ran too deep, that exploded prematurely without causing damage, that struck targets directly and refused to detonate. Japanese merchant captains began reporting American torpedoes lodged unexploded in their hulls while their ships limped safely into port for repairs. The torpedoes were carefully removed by Japanese ordnance personnel who examined them with professional interest and growing confidence. These reports bolstered Japanese confidence that the American submarine threat was manageable, that convoy protection resources could be redirected elsewhere, and that the merchant fleet could operate with minimal escort and still maintain the logistical pipeline feeding Japan's war economy. This assurance influenced strategic decisions regarding resource allocation, shipbuilding priorities, and anti-submarine warfare doctrine. Resources that might have been diverted to constructing escort vessels, developing effective sonar and radar, and training anti-submarine warfare crews were instead allocated to battleships and fleet carriers for the decisive engagement that Japanese naval doctrine anticipated. The assumption that American submarines were ineffective would persist until late 1943, by which time it would be too late to implement the convoy protection and anti-submarine measures that might have preserved Japan's merchant marine. The reality was far more intricate and ultimately far more ominous for Japan than intelligence assessments indicated. The Mark 14 torpedo, designed during the Great Depression when testing budgets were virtually non-existent, suffered from 3 catastrophic defects that masked each other and rendered diagnosis extraordinarily difficult. Understanding how these defects were ultimately identified and rectified requires an appreciation of the torpedo's design, testing, and deployment. The Mark 14 torpedo's development began in 1931, intended to supersede the Mark 10, a World War I-era weapon equipping older S-class submarines. The Mark 14 was conceived for the new fleet submarines then under construction, vessels like the Gato, Wahoo, and Tang, which would form the vanguard of the American submarine force. The design specifications were ambitious. The torpedo would measure 20 feet, 6 inches in length, weigh 3,000 pounds, carry a 643-pound Torpex warhead, and achieve a range of 4,500 yards at 46 knots or 9,000 yards at 31.5 knots. It would be guided by a sophisticated gyroscope system and maintain a set depth regulated by a hydrostatic mechanism. The Mark 6 exploder, a magnetic influence device, was envisioned as a revolutionary component designed to detonate torpedoes beneath enemy vessels, shattering their hulls and ensuring destruction. This exploder represented the pinnacle of technological advancement for its period. Rather than necessitating a direct impact with the target's structure, the Mark 6 was engineered to detect subtle alterations in the Earth's magnetic field, induced by the passage of a ship's steel frame directly above. Upon reaching a predetermined threshold of these magnetic fluctuations, the exploder would activate, triggering the torpedo's detonation beneath the target for maximum impact. Germany had previously experimented with magnetic exploders during the First World War, achieving inconsistent outcomes. British torpedoes had also incorporated magnetic exploders with moderate success. However, the American Mark 6 was developed with the aim of superior sensitivity, enhanced reliability, and greater sophistication compared to any preceding magnetic exploder. The primary obstacle lay in the testing procedures. In 1931, a Mark 14 torpedo incurred a cost exceeding $10,000, an amount equivalent to approximately $200,000 in present-day purchasing power. Amidst the profound economic hardship of the Great Depression, with significantly reduced naval appropriations and congressional scrutiny of every disbursement, The Navy was exceedingly hesitant to expend funds on the destruction of costly torpedoes through live firing exercises. Consequently, the Mark 14 underwent testing utilizing exercise warheads, which were dummy payloads designed for recovery after test launches. These dummy warheads were filled with water and air to closely approximate the weight distribution of the actual combat warhead, then fired at designated targets or through measured trajectories to validate depth control and gyroscope functionality. Following firing, the torpedoes were retrieved, inspected, and subsequently reused. This testing methodology appeared logical and cost-effective. It was, however, entirely insufficient. While the exercise head mimicked the weight of the combat warhead, its weight distribution differed significantly. The actual combat warhead contained 643 pounds of high explosive concentrated in the forward section of the torpedo, whereas the exercise head contained water dispersed throughout the entire warhead section. This disparity in weight distribution adversely affected the torpedo's trim and hydrodynamic characteristics in ways that would only become apparent during actual combat engagements. Furthermore, no live fire tests were conducted against actual enemy vessels to confirm the exploder's proper functioning under combat conditions. The Mark 6 magnetic exploder was so highly classified that submarine captains were forbidden from examining it or comprehending its operational principles. The entire system was approved for combat deployment based solely on theoretical calculations, laboratory evaluations, and exercise firings that never replicated actual battlefield circumstances. The initial deficiency manifested in depth control. The torpedo consistently operated 10 to 11 feet deeper than its intended setting due to the depth control mechanism never having been adequately tested with a heavier combat warhead. When engineers increased the warhead's weight during the final stages of development, adding 80 pounds of additional explosive to enhance lethality, they neglected to recalibrate the hydrostatic depth sensor. Compounding this issue, the sensor was poorly positioned on the torpedo's hull, where water flow generated pressure variations that confused its operation. As the torpedo accelerated to combat speed, the water flowing over the hull created a localized pressure reduction, a phenomenon governed by Bernoulli's principle, akin to the effect that generates lift on aircraft wings. The depth control mechanism, interpreting this pressure drop as the torpedo being too shallow, responded by adjusting the torpedo to run at a deeper setting. The greater the torpedo's velocity, the more pronounced this effect became. Every Mark 14 fired in combat during 1941 and 1942 ran significantly below its designated operational depth. Torpedoes programmed to operate at 10 feet, intended to strike a vessel at its waterline, actually ran at depths of 20 to 25 feet, passing harmlessly beneath their targets. A straightforward laboratory test involving submerging a stationary torpedo in a pool of still water would not reveal this flaw, as the absence of water flow precluded the pressure effect from occurring. Dynamic tests employing exercise heads equipped with depth recorders indicated the torpedo operating at the correct depth. However, the depth measuring instrument within the exercise head suffered from the same positional issue, yielding consistent yet inaccurate readings. The defect was genuine. It impacted every torpedo fired, yet the testing protocol was incapable of detecting it. This sole deficiency would have precipitated substantial problems, but it was obscured by a second flaw, the magnetic exploder. The Mark 6 was engineered to detonate upon sensing the magnetic signature of a ship's steel hull passing overhead. In theory, this was an ingenious concept. The torpedo would proceed beneath the target and detonate under the keel, where the resulting shockwave and gas bubble would be most effective in breaking the ship's structure. In practice, however, the Mark 6 proved exceptionally unreliable. The Earth's magnetic field exhibits significant regional variations, influenced by latitude, local geological formations, and other factors. The Mark 6 had undergone testing in proximity to the Naval Torpedo Station in Newport, Rhode Island, where the magnetic field's strength and orientation were conducive to its proper operation. In combat theaters across the Pacific, particularly in areas such as Java, the Philippines, Guadalcanal, and Japan itself, The magnetic field characteristics were entirely dissimilar. The Mark VI, calibrated for Newport, performed catastrophically in these combat environments. Some torpedoes detonated prematurely, exploding 50 or 100 yards short of their intended targets when the magnetic trigger detected the target's magnetic signature from an excessive distance. These premature detonations inflicted minimal damage, primarily serving to alert the target to the impending attack and allowing for evasive maneuvers. Other torpedoes passed beneath their targets without detonating, as the magnetic field variations were insufficient to activate the exploder in the actual operational setting. Submarine commanders, observing through their periscopes as seemingly perfect shots resulted in harmless premature detonations, grew increasingly disheartened. They repeatedly reported these malfunctions, submitting detailed after-action reports with recommendations to disable the magnetic feature. The Bureau of Ordnance countered by asserting that the issues stemmed from improper maintenance, incorrect calibration procedures, or a failure to adhere to established operating protocols. The deep running defect and the magnetic exploder flaw masked each other, rendering diagnosis exceptionally challenging. Torpedoes operating at excessive depths would not trigger the magnetic exploder, as they passed too far below the target's magnetic influence. Rectifying the torpedo's running depth was presumed to resolve the exploder problem. However, when the depth issue was finally addressed in mid-1942, the magnetic exploder continued to malfunction, and the contact exploder subsequently revealed its own devastating defect. The third defect resided within the contact exploder mechanism itself. The Mark VI integrated both magnetic and contact firing systems into a single unit. Should the magnetic system fail to detonate the torpedo as it passed beneath the target, the contact exploder was designed to activate upon the torpedo's impact with the target's hull. This contact system employed a firing pin design that had functioned reliably in older torpedoes operating at lower speeds. The Mark X, which the Mark XIV superseded, achieved a maximum speed of 36 knots. The Mark VI contact exploder had been designed and tested for that particular speed range. The Mark XIV, however, operated at 46 knots, a 28% increase in speed, and no testing had been conducted to ascertain whether the contact exploder would function correctly at this higher impact velocity. When a torpedo traveling at 46 knots collides with a steel hull, the deceleration is virtually instantaneous and extraordinarily violent. The firing pin within the Mark VI contact exploder was relatively heavy, secured by a spring that needed to be sufficiently stiff to prevent premature detonation during routine torpedo handling, yet weak enough to permit the pin's movement upon striking a target. At the Mark XIV's high impact velocity, especially when the torpedo struck at a 90-degree angle, as submarine commanders were trained to execute, the sudden deceleration caused the firing pin to bind within its housing before it could strike the detonator cap. The frictional forces exerted on the pin during deceleration surpassed the spring's force, which was intended to propel it forward. The consequence was that perfectly executed shots, direct 90-degree impacts precisely as instructed in submarine training, were most likely to result in duds. Only oblique angle impacts, where the deceleration was more gradual, allowed the firing pin to function as intended. This defect had actually been identified and rectified in earlier torpedo models in 1922. The solution involved utilizing a stiffer spring and lighter firing pin components. However, when the Mark VI was designed, incorporating the novel magnetic exploder capability, this earlier lesson was apparently disregarded. The contact exploder inherited the outdated firing pin mechanism without any testing to confirm its efficacy at the Mark XIV's elevated speed. Japanese merchant vessels began arriving in port bearing indentations from American torpedoes, and on occasion, unexploded American torpedoes lodged within their hulls, representing the ultimate humiliation for American submarine crews who had executed flawless attacks. The toll in American lives and missed opportunities throughout 1942 and early 1943 was staggering. Submarine commanders would stalk targets for hours or even days, maneuvering into optimal attack positions at significant risk from Japanese anti-submarine forces, launching volleys of torpedoes that should have guaranteed sinkings, only to witness nothing happen, or to see premature detonations that merely alerted targets without submerging them. The impact on the morale of submarine crews was profound. Men who had trained for years to become elite submarine warriors, who navigated their vessels into perilous situations despite the knowledge that submarines incurred the highest casualty rate of any American combat arm, who risked their lives executing perfect attacks, saw those attacks fail because their primary weapon was fundamentally flawed. Lieutenant Commander Frederick Warder, commanding the submarine Seawolf, encountered an 8,000-ton Japanese transport vessel anchored in Talamo Bay, Philippines, in January 1942. The target was stationary, unescorted, presenting ideal attack conditions. Warder launched 4 Mark 14 torpedoes from point-blank range. He heard 4 dull clangs as they impacted the target's hull. None detonated. The transport, alerted to the Seawolf's presence but undamaged, got underway and commenced evasive maneuvers while calling for air support. Warder reloaded his tubes with older Mark 10 torpedoes, weapons dating back to the First World War, which, while lacking the Mark 14's advanced features, were functional. The first Mark 10 detonated against the transport's stern. Warder fired another, which struck the vessel amidships and broke its back. The transport sank within minutes. Warder's after-action report unequivocally stated that the Mark 14 was defective and should be immediately drawn from service. The Bureau of Ordnance not only disregarded his recommendation, but, in its response, suggested that Warder required additional training in proper torpedo maintenance procedures. Lieutenant Commander Eugene McKinney, commanding the submarine Tambor, fired 8 torpedoes at a Japanese destroyer in April 1942 from a range of 800 yards. He heard 8 dull metallic clangs as they struck the destroyer's thin hull plating. None detonated. The destroyer, now fully aware of the Tambor's position and bearing, launched a counterattack with depth charges that came close enough to shatter light bulbs throughout the submarine and cause leaks in multiple systems. The Tambor narrowly escaped, surfacing after dark in heavy seas to ventilate the vessel and perform repairs. McKinney recovered 8 of his torpedoes floating on the surface, their warheads unfired. He meticulously examined them and transmitted a scathing report to Pearl Harbor detailing his observations. The Bureau of Ordnance's response accused him of improper torpedo handling and poor maintenance practices that had led to the exploders malfunctioning. Japanese intelligence intercepts of these communications, partial decryptions of American submarine radio traffic, and reports from informants in American-controlled ports noted that American submarine commanders were attributing combat failures to their own weaponry. This was interpreted as clear evidence of inadequacy and deficient training. Japanese anti-submarine doctrine, never prioritized due to intelligence assessments that maintained submarines did not pose a significant threat, remained focused primarily on protecting naval task forces rather than merchant convoys. Destroyer escorts and patrol craft, designed predominantly for surface engagements, lacked effective sonar, adequate depth charge armament, and tactical doctrines for submarine hunting. Japanese naval construction priorities were concentrated on battleships and fleet carriers for decisive engagements, not on less glamorous escort vessels for convoy protection. The breaking point for the torpedo crisis arrived with 2 incidents during June and July of 1943, which ultimately compelled the Bureau of Ordnance to acknowledge the reality of the situation. On June 10, 1943, the submarine Trigger, under the command of Commander Roy Benson, encountered the fleet aircraft carrier Shokaku, one of Japan's most valuable capital ships and a critical asset for Japanese naval aviation. Benson executed a textbook approach, maneuvering the Trigger into an optimal attack position at a range of 1,200 yards, a distance so close that a miss was virtually inconceivable. He launched 6 torpedoes in a meticulously calculated spread designed to ensure multiple hits irrespective of the target's evasive maneuvers. 2 torpedoes missed due to the Shokaku's emergency turn. 1 detonated prematurely 80 yards short of the target, its underwater explosion visible through the Trigger's periscope, but causing no damage. One torpedo was a dud, striking the Shokaku's hull and failing to explode. Two torpedoes hit and detonated as intended, inflicting moderate damage that reduced the Shokaku's speed and ignited fires. The Shokaku, protected by its destroyer escorts, which immediately commenced depth charge attacks on the trigger's probable location, limped away for repairs rather than sinking. The carrier underwent emergency repairs at the Kura Naval Arsenal and was back in service within 6 weeks. She would later participate in the Battle of the Philippine Sea on June 19, 1944, where her aircraft would engage American carriers before she was finally sunk by the submarine Archerfish. That single torpedo failure on June 10, 1943, with 2 torpedoes out of 6 failing to function as designed, cost the United States a fleet carrier at a time when every carrier was desperately needed in the balance of naval power in the Pacific. The loss of the Shokaku in June 1943, instead of June 1944, might have prevented her aircraft from participating in combat actions that resulted in American casualties. The torpedo failures had strategic repercussions that rippled throughout the entire course of the war. The second incident proved even more definitive in forcing the Bureau's action. On July 24, 1943, Lieutenant Commander Lawrence Daspit, commanding the submarine Ticonderoga on her second war patrol, sighted the 19,250-ton whale factory ship Tonan Maru No. 3, operating alone and unescorted south of Truk. This presented a submarine commander's dream target. The vessel was enormous, slow, defenseless, and carried vital whale oil for Japanese industry. Whale oil was utilized in the production of nitroglycerin for explosives, in food products, and in various industrial processes. Sinking her would inflict both immediate material loss and longer-term economic damage. Daspit maneuvered the Ticonderoga into an attack position at a range of 4,000 yards and launched 4 torpedoes. He observed 2 hits that brought the ship to a complete stop. Daspit immediately fired 2 more torpedoes. Both hit. 6 torpedo hits should have been more than sufficient to sink any merchant vessel. The Tonan Maru No. 3 remained afloat, dead in the water, but refused to sink. With no enemy anti-submarine forces in sight, Daspit had ample time. He meticulously maneuvered the Ticonderoga into a textbook-perfect position, 875 yards directly abeam of the target, where missing was impossible, and every torpedo would strike at the optimal 90-degree angle. He launched 9 more torpedoes, observing each one carefully through his periscope, despite Japanese machine gun fire from the target ship. All 9 hits struck the stationary target squarely at the optimal angle. None exploded. Daspit heard the dull thuds of impact through the Ticonderoga's hull. Not a single torpedo detonated. Daspit, suspecting he had received a faulty production batch from the torpedo factory, kept his last torpedo unfired for analysis by experts back at Pearl Harbor and cleared the area before Japanese aircraft could arrive. He had fired 15 torpedoes at an ideal target under perfect conditions. 6 had hit and failed to explode. 9 had hit and failed to explode. None had detonated prematurely or run wild. All had functioned perfectly, except for the one critical function of exploding. Rear Admiral Charles Lockwood, commander of submarine forces, Pacific Fleet, since January 1943, recognized that Daspit's experience represented a controlled experiment conducted under combat conditions. Lockwood himself was an experienced submariner, having commanded submarines in the 1920s and 1930s before assuming senior leadership positions. He had listened for 2 years to his submarine commanders reporting torpedo failures. He had observed as the Bureau of Ordnance attributed every failure to operator error, poor maintenance, or improper attack procedures. He had witnessed the detrimental impact on the morale of submarine crews who were risking their lives executing perfect attacks only to have their weapons malfunction. He had read the intelligence reports indicating that Japanese merchant ships were arriving in port with unexploded American torpedoes lodged in their hulls. He now possessed documented proof in Daspit's patrol report, complete with photographs and detailed observations, that the contact exploder was fundamentally defective. Lockwood ordered immediate testing. His staff established a testing range where dummy warheads could be dropped from a pier crane onto steel plates positioned at various angles to simulate torpedo impacts. The tests revealed that the firing pin mechanism bound and jammed at high impact velocities, particularly at 90-degree impact angles. The heavier the firing pin and the more abrupt the deceleration, the greater the likelihood of binding. Direct 90-degree hits, the supposedly perfect shots that submarine commanders were trained to execute, generated such sudden deceleration that the firing pin could not move rapidly enough to strike the detonator cap. The contact exploder was fundamentally defective, and the defect was exacerbated by perfect shooting. The solution emerged from an unexpected source. During the attack on Pearl Harbor, American anti-aircraft fire had downed several Japanese aircraft. Engineers examining the wreckage at the Naval Air Station discovered that the propeller blades were constructed from a lightweight aluminum alloy, rather than the steel utilized in American propellers. This material, sufficiently strong for its intended purpose but significantly lighter than steel, suggested a potential solution to the firing pin problem. If the firing pin were fabricated from lightweight aluminum instead of steel, it would possess less inertia during deceleration and would be less prone to binding. Tests confirmed the theory. By September 1943, 21 months after the attack on Pearl Harbor, modified torpedoes equipped with aluminum firing pins and other design enhancements began reaching submarines at Pearl Harbor and Fremantle. The transformation in American submarine effectiveness following September 1943 represented one of the most dramatic capability shifts in the history of naval warfare. From December 1941 through August 1943, American submarines operated with their primary weapon barely functional. 3 distinct catastrophic defects, each masking the others, had rendered the Mark 14 torpedo unreliable at best and completely ineffective at worst. Submarine crews had implemented improvisations to the best of their ability, setting torpedoes to operate at shallower depths to counteract issues with depth control mechanisms, disabling magnetic exploders against explicit directives to prevent unintended detonations, and attempting shots at oblique angles instead of the precise 90-degree angles they had been instructed to employ. However, these were merely palliative measures, temporary fixes that addressed symptoms without resolving the fundamental problem. Following September of 1943, once all 3 inherent flaws had been rectified, the Mark 14 torpedo evolved into the formidable weapon it was originally intended to be. Depth control now functioned flawlessly. The magnetic exploder was permanently deactivated, reverting to solely relying on contact detonation. The contact exploder now operated dependably across all impact angles and velocities. Submarine captains who had honed their expertise through arduous combat, who had endured 2 years of warfare despite employing faulty ordnance, were now equipped with torpedoes that performed as expected. The impact on Japanese shipping was immediate and devastating. Japanese naval strategists, observing early American submarine operations throughout 1942 and the initial months of 1943, had concluded that the submarine menace was manageable. Resources dedicated to convoy protection were prioritized for safeguarding naval task forces and troop transports rather than merchant vessels. Destroyer escorts and patrol craft focused on defending battleships and aircraft carriers. Anti-submarine warfare doctrine emphasized the defense of high-value military assets. The merchant fleet, responsible for transporting raw materials from conquered territories to Japan and delivering finished military goods from Japan to forward outposts, operated with minimal escort, operating under the presumption that American submarines lacked the effectiveness to pose an existential threat to Japanese maritime supply lines. This evaluation proved disastrously incorrect once American torpedoes began to function reliably. The submarine Flasher, under the command of Commander Reuben Whitaker, intercepted a convoy en route to China on the 22nd of December, 1944. Whitaker skillfully maneuvered his vessel into an attack position and launched 6 torpedoes at 3 oil tankers. All 6 torpedoes performed flawlessly. 3 tankers, the Omarosan Maru, weighing 10,000 tons, the Arita Maru, weighing 9,200 tons, and the Otoasan Maru, also weighing 9,200 tons, all carrying vital fuel oil from the Dutch East Indies to Japan, were sunk in less than 20 minutes. In a single engagement, Whitaker had annihilated over 28,000 tons of shipping and dispatched hundreds of thousands of gallons of irreplaceable fuel to the ocean depths. The submarine Barb, captained by Commander Eugene Fluckey, achieved even more remarkable success. During its 11th war patrol in 1945, the Barb sank 17 vessels, totaling over 96,000 tons, establishing a record for tonnage sunk in a single patrol that would never be surpassed. On the 23rd of June, 1944, operating off the coast of China, Fluckey executed an assault on a convoy in Namuan Harbor. In a mere 54 minutes of intense combat, the Barb sank 4 ships, accumulating over 15,000 tons. These were not a matter of chance or random fortune. These were meticulously executed attacks, utilizing ordnance that now functioned as designed, deployed by submarine commanders who had learned through harsh experience precisely how to employ them to their fullest potential. The statistics clearly illustrated this transformation. In 1942, American submarines fired 1,442 torpedoes and claimed 211 ships, accounting for 1.3 million tons. The actual results were 109 ships, totaling 41,871 tons. In 1943, as the torpedo issues were progressively resolved, submarines launched 3,937 torpedoes, sinking 284 ships, totaling 1,349,473 tons. In 1944, with fully operational torpedoes, submarines discharged 6,920 torpedoes, sinking 492 ships, totaling 2,388,000 tons. The improvement in effectiveness was approximately tenfold once the torpedoes began functioning as intended. By the conclusion of the war, American submarines had sunk 1,178 Japanese merchant vessels, amounting to 5,503,491 tons, representing 54.6% of all Japanese shipping losses from all causes. More critically, they had sunk 201 naval vessels, including the aircraft carrier Shinano, the largest carrier ever constructed at 72,000 tons displacement and the largest warship ever sunk by a submarine. The repercussions for Japan's economy were catastrophic, fundamentally altering the strategic equilibrium in the Pacific. Japan, an island nation, was entirely reliant on maritime logistics. Raw materials from conquered territories in Southeast Asia, China, and the Dutch East Indies had to be transported to Japan for processing. Finished military equipment needed to be shipped from Japan to forward bases and combat zones. Food imports were essential for sustaining the populace. Oil from the Dutch East Indies was critical to every facet of the war economy and military operations. By January of 1945, the Japanese merchant fleet had been reduced to scarcely a quarter of its strength as of December 1941. Tankers transporting oil from the East Indies were being sunk at a pace exceeding their ability to complete round trips. Cargo ships laden with raw materials were succumbing to the depths with their holds full. Food imports had declined to such an extent that rationing in Japan approached starvation levels. The industrial ramifications permeated every aspect of Japan's war effort. Oil refineries on the home islands ceased operations due to a lack of crude oil from the East Indies. Japan's petroleum production, which had never been adequate for military requirements, even with imports from the Dutch East Indies and Borneo, collapsed to negligible levels. Steel mills shuttered for want of iron ore and coking coal. Aircraft factories halted production due to a scarcity of aluminum, which had to be imported as Japan possessed virtually no domestic aluminum production capabilities. Training programs for pilots and sailors ground to a standstill from a lack of fuel. Naval vessels remained moored at piers or at anchor, immobilized by a shortage of oil. The combined fleet, once the third largest navy globally, and a force that had vanquished the Russian Navy at Tsushima and dominated the Western Pacific in 1942, was rendered immobile by a dearth of fuel for its ships. Army divisions stationed in China, Southeast Asia, and the Pacific Islands dwindled from a lack of provisions and reinforcements. Ammunition, replacement armaments, medical supplies, and sustenance all had to be dispatched from Japan. Increasingly, those shipments never reached their destinations. Troops in isolated garrisons endured months without resupply, as submarines annihilated the freighters that constituted their lifeline. Battle casualties could not be replaced, as troop transports carrying reinforcements were torpedoed and sunk. The Japanese army, which had subjugated vast territories and defeated Chinese, British, Dutch, and American forces in the initial months of the war, found itself slowly starving in its fortified positions because the logistical framework sustaining it was being systematically dismantled by American submarines. The home islands faced the specter of widespread starvation as food imports ceased. Japan had never been self-sufficient in food production, relying on imports from Korea, Formosa, and Southeast Asia to feed its population. By 1945, those imports had dwindled to a mere trickle due to submarine attacks on cargo vessels. Urban populations in Tokyo, Osaka, Kobe, and Nagoya endured escalating hunger as rice rations were repeatedly reduced. Black markets thrived as desperate civilians paid exorbitant sums for food. The government implemented draconian measures to maintain order, but the stark reality was that Japan could not adequately provision its populace without imports, and submarines had severed those supply lines to unsustainable levels. American strategic bombing, which garnered considerable attention in popular accounts and post-war analyses, was in fact secondary to the submarine blockade in undermining Japan's capacity to wage war. The Army Air Force's incendiary bombing campaigns against Japanese cities, while devastating to civilian populations and psychologically traumatic, had a limited immediate impact on Japan's war economy because that economy had already been crippled by a deficit of raw materials. Factories were incapable of operating without steel, aluminum, coal, and oil, irrespective of whether they were under bombardment. The atomic bombs dropped on Hiroshima and Nagasaki on the 6th and 9th of August, 1945, provided the Japanese government with a face-saving pretext for surrender. However, Japan had already been economically and militarily defeated by that juncture. The nation simply could not sustain its wartime efforts, regardless of battlefield outcomes, because the economic bedrock of its war endeavor had been pulverized by submarines. The ultimate irony of this narrative pertains to the Type 93 Long Lance torpedo, the weapon that had instilled terror in Allied navies in 1942 and 1943, and which Japanese intelligence had cited as evidence of technological superiority. By 1944, as American forces developed countermeasures and tactical doctrine to overcome it, the Long Lance became increasingly peripheral to the war's outcome. Radar warning systems provided American ships with advance notice of approaching Japanese surface formations, enabling evasive maneuvers before torpedoes could be launched. Enhanced damage control techniques assisted ships in surviving torpedo impacts that would have rendered them defunct earlier in the conflict. Tactical formations designed to minimize exposure to torpedo attacks diminished the efficacy of long-range torpedo salvos. Most significantly, increasingly assertive American surface forces, bolstered by overwhelming air power, annihilated Japanese torpedo-launching platforms at a pace exceeding Japan's replacement capacity. By 1944, American cruisers and destroyers engaged Japanese surface fleets with a confidence derived from technological advantages that eclipsed Japanese torpedo range. American vessels possessed radar fire control systems that facilitated accurate gunnery during nighttime engagements and in conditions of poor visibility. They maintained reliable radio communication networks that enabled coordinated fleet operations. They enjoyed numerical superiority in virtually every engagement. The weapon that should have represented Japan's decisive edge in surface combat became a secondary concern as American submarines systematically dismantled the merchant fleet that sustained the Japanese war machine. Japanese destroyers and cruisers, engineered for devastating torpedo assaults in night surface actions, found themselves relegated to escort duties, protecting the remnants of the merchant fleet, a role for which they were ill-suited and which they performed inadequately. The Battle of the Philippine Sea in June of 1944 starkly illustrated the complete inversion of the naval power balance. On the 19th of June 1944, the submarine Kavala, under the command of Commander Hermann Kosler, intercepted the Japanese fleet carrier Shokaku as the carrier was recovering aircraft following strikes against American forces. Kosler unleashed 6 torpedoes from a range of 1,200 yards. 4 found their mark, their detonations igniting aviation gasoline reserves and triggering catastrophic secondary explosions. Shokaku, a veteran of Pearl Harbor, the Coral Sea, and the Santa Cruz, the flagship of Japanese carrier operations in 1942, sank within minutes, taking 1,263 crew members with her. Hours later, the submarine Albacore, commanded by Commander James Blanchard, fired a single torpedo at the brand-new armored carrier Taiho, Japan's most advanced carrier and the flagship of the mobile fleet. The torpedo struck the forward section, causing what appeared to be minor damage. Japanese damage control officers, confident that the heavily armored carrier could withstand a single torpedo hit, committed a fatal error. They attempted to ventilate gasoline vapors by operating the ventilation system at maximum power, dispersing explosive fumes throughout the vessel. 7 hours after the torpedo impact, at 15:32 hours, the Taiho exploded in a massive detonation that ruptured its sides and broke its hull. It sank rapidly, taking 1,650 sailors with it, including Vice Admiral Jizaburo Ozawa's entire staff. These were not fortunate strikes or serendipitous occurrences. These were precisely executed attacks employing weapons that functioned as designed against targets whose loss Japan could ill afford. Shokaku and Taiho constituted 40% of Japan's remaining large carrier force. Their loss on a single day, both to American submarines, crippled Japanese naval aviation at the critical juncture when it confronted the American fast carrier task force in the Philippine Sea. The Battle of the Philippine Sea, colloquially known to American pilots as the Great Marianas Turkey Shoot, annihilated Japanese carrier air groups so thoroughly that Japanese carriers would never again pose a significant threat to American naval forces. American carrier aircraft shot down over 600 Japanese aircraft in a single day while losing 29 of their own. The submarines had struck first, eliminating 2 irreplaceable fleet carriers before American carrier aircraft even engaged the Japanese fleet. Japanese naval planners, still operating under intelligence assessments that had categorized American submarines as a secondary threat, had positioned their carriers in waters frequented by American submarines without adequate anti-submarine screening. The outcome was catastrophic. The loss of these carriers meant that even if Japanese naval aviation could train replacement pilots and rebuild air groups, there were insufficient carriers to deploy them. Japanese naval aviation, which had dominated the Pacific skies in 1942, ceased to be an effective fighting force by mid-1944, and American submarines had delivered the decisive blows that rendered that defeat inevitable. The Battle of Leyte Gulf in October of 1944 demonstrated the cumulative impact of the submarine campaign and the complete reversal of the technological balance. On the 23rd of October 1944, as Admiral Takeo Kurita's center force approached the Philippines through the Palawan Passage, navigating narrow waters en route to Leyte Gulf, the submarines Darter and Dace intercepted the column. The submarines were positioned along the anticipated transit route based on superb intelligence derived from code-breaking operations, showcasing the integration of communications intelligence with tactical operations that defined American submarine warfare. By 1944, at 05:32 hours, the Darter, commanded by Commander David McClintock, detected the Japanese column on radar at a range of 30,000 yards. He maneuvered his vessel into an attack position, tracking the force for 4 hours while relaying contact reports that enabled the Dace, under the command of Commander Bladin Klaget, to position itself for a coordinated assault. At 09:27 hours, the darter launched 6 torpedoes targeting the heavy cruiser Otago, Admiral Kurita's flagship. 4 torpedoes struck home, their explosions gouging immense holes in Otago's hull below the waterline. Otago lost all electrical power instantaneously. Her engine spaces flooded, and she began to sink rapidly. Admiral Kurita and his staff abandoned ship, swimming in the oil-slicked water as destroyers maneuvered to rescue them. Otago sank at 09:55 hours, a mere 28 minutes after the torpedo impacts, taking 360 of her crew of 800 with her. The darter immediately shifted targets, launching 4 torpedoes at the heavy cruiser Takao. All 4 found their mark, the explosions breaking Takao's keel and flooding multiple compartments. Takao did not sink immediately. Her crew managed to isolate flooded sections and keep her afloat. However, she was so severely crippled that she had to withdraw from the battle, escorted by 2 destroyers. She would spend the remainder of the war undergoing repairs in Singapore, never returning to active service. The Dace, firing from the opposite flank of the Japanese column, targeted the heavy cruiser Maya, launching 4 torpedoes at 09:56 hours. Multiple torpedoes struck home, their explosions breaking Maya's keel and detonating her magazines. Maya broke in half and sank in 8 minutes, taking 769 of her crew of 1,000 with her. In a single, coordinated attack lasting less than 30 minutes, 2 American submarines had sunk 2 fleet cruisers, crippled a third, and deprived the commander of the center force of his flagship, his staff, his command center, and effective communications at the commencement of the largest naval battle in history. Admiral Kurita transferred his flag to the battleship Yamato, but he had lost his communications equipment, his charts, his operations staff, and critical hours during the transfer. His subsequent performance at Leyte Gulf, characterized by hesitation, confusion, and ultimately withdrawal, despite having American landing forces within his grasp, may be partially attributed to the submarine attack that disrupted his command structure at the crucial moment. Whether Kurita would have pressed his attack more aggressively with his original staff and command facilities aboard the Otago is unknowable, but the submarine attack undeniably contributed to the uncertainty that led him to withdraw when success was within reach. The broader strategic consequence of Leyte Gulf was that the Imperial Japanese Navy ceased to exist as an effective fighting force. Japan lost 1 fleet carrier, 3 light carriers, 3 battleships, 6 heavy cruisers, 4 light cruisers, and 11 destroyers. The surviving vessels, including the super battleship Yamato, were confined to home waters by fuel shortages resulting from submarines sinking tankers at a rate Japan could not replace. Yamato possessed sufficient fuel for only a one-way voyage when she departed in April of 1945 for a suicidal mission against American forces at Okinawa. She was sunk by carrier aircraft before ever reaching her objective, going down with 2,498 of her crew of 3,332. The remaining carriers, devoid of fuel to train replacement pilots or conduct combat operations, remained idle while their aircraft were expended in kamikaze attacks. The decisive fleet engagement for which Japanese naval doctrine had prepared for 40 years had been fought and lost, not due to inferior tactics or insufficient courage, but because the logistical infrastructure that sustained the fleet had been annihilated by American submarines that Japanese intelligence had catastrophically underestimated. By early 1945, Japanese shipping losses had reached apocalyptic proportions, rendering the continuation of the war economically unfeasible. American submarines, operating with reliable torpedoes, sophisticated intelligence regarding convoy routes gleaned from code-breaking operations, and aggressive commanders who had honed their skills in the crucible of combat, intercepted and destroyed shipping at a rate Japan could not sustain. In January of 1945, American vessels sank 252,000 tons of Japanese merchant shipping. In February, 182,000 tons. In March, 269,000 tons. In April, 186,000 tons. Each month, submarines were sinking the equivalent of Japan's entire monthly shipbuilding capacity several times over. Each sinking represented not merely lost cargo, but lost crews, diminished shipbuilding capacity, a reduction in strategic mobility, and another step toward economic collapse. Japanese shipyards, working furiously to replace losses, could construct approximately 300,000 tons of merchant shipping annually at maximum capacity, assuming they had access to steel, labor, and electrical power, all of which were increasingly scarce. American submarines were sinking more than 3 times that tonnage each month. The mathematics were simple and stark. Japan's merchant capacity was declining inexorably towards zero, irrespective of any successes the Japanese Navy or Army might achieve on the battlefield. By August of 1945, Japan possessed virtually no remaining merchant marine. The vessels that survived did so by seeking refuge in ports, reluctant to venture into waters patrolled by American submarines that controlled the seas with a totality unmatched by any naval force in history. The human toll of the submarine campaign remains challenging to quantify precisely, but it was undeniably devastating for Japanese merchant sailors. These men, civilians serving aboard merchant vessels, perished by the thousands as submarines torpedoed their ships, trapped below decks as torpedoes blasted gaping holes in hulls, drowning in oil-filled waters, consumed by flames when tankers erupted, or succumbing to exposure in lifeboats that drifted for weeks without rescue. Japanese merchant sailors endured horrific suffering. The Imperial Japanese Navy provided no meaningful aid to imperiled merchant mariners, considering them mere civilian expendables rather than vital national assets deserving of protection. Numerous American submarine captains, though operating under orders for unrestricted naval engagement, still possessed a core of humanity. They would surface after engagements to offer rescued sailors essential provisions, sustenance, and navigational guidance to the nearest landmass. Conversely, Japanese military personnel, conditioned through intense propaganda to perceive Americans as cruel and prejudiced, frequently rejected offers of assistance. They would actively swim away from potential rescuers or obstinately refuse aid, unwilling to accept successity from adversaries they had been indoctrinated to believe were subhuman. The Japanese disregard for advancements in American torpedo technology serves as a stark illustration of how critical intelligence lapses can escalate into catastrophic strategic blunders. Faced with incontrovertible proof of significant American torpedo malfunctions in 1942, Japanese analysts concluded that American armaments were inherently deficient and destined to remain so. This flawed assessment consequently dictated resource allocation priorities, favoring the pursuit of decisive fleet engagements over the crucial tasks of protecting shipping convoys and combating enemy submarines. As American engineers diligently identified and rectified every flaw in their torpedoes, Japanese intelligence services were remarkably slow to acknowledge these improvements and even slower to persuade frontline commanders to adapt their strategies and tactics accordingly. By the time Japanese naval strategists grasped the true extent of the submarine menace, it was irrevocably too late. Vessels had already been submerged, the merchant fleet annihilated, and the nation's economy crippled beyond repair. The ultimate triumph in the Pacific War was not secured through the dramatic carrier clashes at Midway and the Philippine Sea, which captured public fascination and dominated news cycles, but rather through the relentless, attritional warfare waged by submarines, which systematically dismantled Japan's capacity to sustain its military operations. The very weapon Japanese intelligence had derided as evidence of American ineptitude ultimately became the instrument of Japan's downfall, demonstrating a grave error nations commit at their existential peril when they dismiss an adversary's potential based on initial setbacks. The American submarine offensive represented industrial warfare at its most brutal and effective, showcasing how superior numbers, robust logistical networks, and advanced engineering prowess can overcome early technical deficiencies to achieve victory through sheer, unyielding pressure that the enemy cannot withstand or counter. Japan's naval power did not succumb in a blaze of heroic combat, but rather withered under the cold, hard arithmetic of lost tonnage versus production capacity, a calculation where American industrial might, compounded by Japanese intelligence failures, inexorably led to defeat. The submarines that Japanese intelligence had carelessly dismissed as ineffective and equipped with faulty weaponry evolved into the force that ultimately suffocated the Japanese empire. They sank more tonnage than all other American naval assets combined, dismantling the vital maritime logistics system essential for an island nation's survival. This campaign underscored that victories are forged not solely through tactical brilliance or operational finesse, but by confronting the stark economic realities of industrial capability, the availability of resources, and the capacity to learn from mistakes and implement corrective measures. Japanese intelligence failed to comprehend that the shortcomings observed in American torpedoes in 1942 were merely transient technical challenges, which American engineering and industrial might would inevitably resolve, rather than permanent indicators of inherent inadequacy. This failure of foresight and accurate assessment proved devastatingly costly for Japan, leading to the loss of the war.